Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening to both panels. So my name is Anas bin Baharin and I am from 4BNM. First of all, I would like to thank Dr. Siti Hana binti Nasir as my supervisor, and the second one is my co-supervisor, which is Dr. Amirul Shafiq bin Sadun. Without them, without their guidance, I would never complete my final year project this year. And for the title of my project, I am now representing the study of the design improvement for a mobile rugby ball launcher robot for indoor training purpose. Okay, now we proceed to the abstract. So the main focus of previous project is to construct the hardware and software of semi-automated rugby launcher robot. So mobile rugby launcher robot were designed for a primary school kid as a first introduction to a rugby sport game. In terms of operation system, it allows MR launcher become more reliable and efficient with this semi-automated control process. The previous research simulates how it can be controlled by using remote control system due to features applied in MR launcher. As to continue the research made, there are several rooms detected as for the improvement, which is the storage still needed due to increase the usefulness and benefits to society. Okay, now we move to the introduction. So, as for introduction for this project, the lack of storage is affecting the time dilation in order to pick and pass the ball. Other than that, based on the existing rugby ball launcher, there are no specific storage mechanism that are built in them. Due to the oval-shaped ball, it is difficult to design a structure of the storage and identify the appropriate mechanism improvement needed. Thus, this project proposed design for the storage mechanism in MR launcher, which combined with an automatic ball feeder mechanism with high accuracy and precise as to reduce time dilation of the process control. Okay, now we proceed to the literature review. So as we can see here in the table 1, it shows previous study on launcher machine that contain a storage. So the first research that made by Henry Williams, which is ping pong ball launching system. So his innovation on his research is enhancing solo practice mode by adding new features to the robot. So according to the second research made by U. Aravind and A. Satyasilan, which is design and fabrication of soccer shooting machine in 2020, so their innovation is creating design that provide independent movement, loading or unloading balls. Okay, the third research for this project is fabrication of football launching machine. The research was made by Prashant and his assistant Prof. Pashinavar in 2021. So their innovation in their research is enhancing and automatic reloading and receiving of in-ball launcher system. Okay, now we proceed to the methodology. So as we can see here, this is an actual working steps of MR launcher. So the first figure we can see here, we need to set up at least three balls on MR launcher, which is the first ball in the launch room and two other balls in the storage room. So the feeder mechanism will feed the ball through rotating wheels, and then the balls will launch, and then the sensor will detect the ball once it went through it, and then the ball stopper immediately release the ball once within 2 seconds, and then the ball stopper will hold the next ball from falling to the launch room, and then the process will be repeated until all the balls have been shot. Okay, now we proceed to the next methodology, which is the testing method. So as we can see here, this is a visual of shooting test. which is the first test we use with 1 meter distance, and followed by 3 meter distance, and the last one is 6 meter distance. Okay, the second test that we use in this project is multi-directional movement test, which is the test required to move the ML launcher in 8 different trajectories. The first one is forward, and followed by backward, right, left, and then forward right, forward left, and then backward right, and the last one is backward left. Okay, now we proceed to the results and discussion. So as we can see here, from the table 2, there is data collected for shooting test. So in this table, we can see that the motor speed set by 500 RPM, and the second one is 1000 RPM, and the last one is 1500 RPM. So 500 RPM successfully shot with 1 meter distance, and then followed by 3 meter distance, and the last one is 6 meter distance. So as we can see here, both 500 and 1000 meters had passed the test successfully, while the third test with 100 and 500 RPM had 2 fails in each attempt, which is the sensor can detect the projectile of the ball due to height distance when the ball gets shot. So the result for the second test is, as the recorded result shown, ML launcher passed the test, which able to move 8 different trajectories without any obstacles. Through the test result, it was proved that an invented of the storage improvement does not affecting the ability of ML launcher to be moved in multi-directional movement. So overall, it was stable enough to keep the ball from falling out of the storage, since the design of the storage mechanism was compatible to the current body of ML launcher. So as the conclusion for this project is, the sequences of the storage mechanism were completely achieved as the essential of the project aim. All the materials and components used were simply met the criteria needed, and then the overall data for this project was collected in terms of shooting parameter and mobility of the robot. And the last one is the enhanced storage mechanism was manifested as the product upgrade instead of downgrade. So according to the references that have been made to complete this project, basically based from previous research, articles and journals, and also patents. So that's all from me. Thank you. Assalamualaikum.